Welcome, everyone. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info.
Have you ever, noticed how your favorite apps seem to evolve almost constantly? New features just appear, bugs vanish, and updates roll out without everything breaking.
Yeah, it can feel pretty seamless when it's done right.
It's almost like magic, isn't it?
Okay.
And today we're going to pull back the curtain on that magic, diving deep into the world of DevOps and CI/CD pipelines.
And, this isn't just about getting software out faster. It really represents a profound shift in how teams collaborate, how they innovate, and how they guarantee quality, really, at an unprecedented scale. We're talking about moving from these long development cycles, measured in months, to getting features into users' hands in, well, sometimes minutes. It's a fundamental change, right? Impacts everything. So our mission today is to sort of demystify these powerful concepts, look at the tools that make it happen, and then ground it all with a real-world project that actually put these ideas into practice. Get ready to connect some pretty significant dots, I think. We often hear DevOps described as, smashing development and operations together. But what's truly transformative about it, beyond just the name, what's the real shift?
Yeah, you're right to focus on the shift part, because that's really the core of it. I mean, the term itself popped up around 2009 at Flickr, John Allspaw, and Paul Hammond.
Oh, wait, Flickr.
Yeah, but its real power, its lasting impact, is in fostering this organizational culture. Transparency, communication, deep collaboration. It's fundamentally about breaking down those old silos.
On walls where developers would just throw the code over to ops and say, here you go, make it run.
Yeah. Exactly that us versus them thing. DevOps is about shared responsibility. It's key. Developers start understanding the operational challenges, and the ops teams, they provide quick, constructive feedback right back to dev.
Okay.
The whole goal is consistent, efficient, reliable delivery of applications, at scale. Everyone's pulling in the same direction for the product's success.
So if you've ever been really frustrated by a buggy update or a feature that just takes forever to show up, understanding this cultural change is kind of the first step to seeing why things are getting better.
Absolutely.
So with that cultural foundation set, where does CI/CD fit in? Continuous integration and continuous delivery or deployment. It feels like the machinery, the engine driving the DevOps philosophy.
That's a perfect way to put it. CI/CD is the practical, concrete implementation of those DevOps principles. It's really a set of practices, automated practices, designed to monitor and control the stages of software development.
From integration testing all the way to deployment.
Right. It's all about making sure your code is always essentially in a releasable state.
Okay, let's break that down. Starting with the CI part, continuous integration. What does it actually look like day to day for a dev team?
Okay, so CI. It's an automated process where developers frequently merge their code changes, and we're talking small, frequent changes ideally, into a shared main repository, like a main branch in Git.
Right, small commits.
Exactly. And each time they do that, it automatically triggers a build of the software and runs a whole suite of automated tests. The real magic here isn't just the automation, it's the speed of the feedback loop.
Ah, okay.
Problems get caught literally within minutes of being introduced, not days or weeks later when you're trying to merge everything together. It prevents that, integration hell.
Got it. So making small, frequent changes means less risk each time. And then we get to CD, which, as you said, can mean two things. Continuous delivery or continuous deployment. Can you unpack that difference for us? It tricks people up.
It really does. Yeah, it's a crucial distinction. So both happen after CI, and both are about getting that tested code closer to users, error-free. With continuous delivery, your code changes are automatically built, tested, and then prepared for release to a production-like environment, maybe a staging server.
Okay.
The key point is the software is always deployable. It's ready to go live with just a manual trigger, like someone pushing a button. You have the option to release at any time.
So ready, but needs a final okay.
Precisely. Now, continuous deployment. That takes it one big step further. Every single change that passes all the automated tests in the pipeline, it gets automatically deployed straight into the production environment.
Wow, no human intervention.
None. It goes right out to end users. It's the ultimate in speed and automation, but obviously it requires immense confidence in your automated testing and monitoring. You really need to trust your process.
That's a massive difference. So when you see your favorite app push out a quick bug fix almost overnight, chances are you're seeing continuous deployment in action. it totally changes how fast we get improvements.
Yeah, it's transformative for the user experience.
So, okay, beyond the definitions, what are the sort of tangible, real-world wins here? For businesses and ultimately for us as users, why make this big investment in automation?
Oh, the advantages are huge, really game-changing. Think about uh, rapid feedback loops. Like we said, issues get found and fixed almost instantly. This fosters incredibly tight communication between dev and ops.
Right.
Real-time updates, new features, critical security patches, bug fixes that can be integrated and pushed out super quickly. Your product stays fresh and secure.
Makes sense.
Quick fault isolation. Because the changes are small and frequent, if a bug does manage to slip through, it's way easier and faster to find where it came from and fix it.
Okay, less digging.
Much less digging. Then there's increased test reliability. This constant, focused, automated testing leads to higher quality releases. And it drastically cuts down the mean time to resolution, the MTTR, for any production problem.
MTTR, yeah, important metric.
Very. And maybe underpinning all of this is improved collaboration.
Yeah.
Teams just become naturally more connected, more accountable. It leads to a much healthier and, frankly, more productive environment.
So it really sounds like it's not just about going faster, but about building fundamentally better, more solid software and doing it in a way that's, well, less painful and more satisfying for the people building it too.
Exactly. You hit the nail on the head. It translates directly into lower operational costs, fewer critical bugs hitting users, and ultimately way higher customer satisfaction because they're getting a better product faster, more consistently.
Yeah, if your go-to app just keeps getting better week after week and rarely crashes on you, you're probably feeling the direct benefits of a really well-oiled CI/CD pipeline.
That's it.
Okay, talking about it conceptually is one thing, but seeing it in action is another. Let's dive into a specific example. You mentioned a case study, the Mumu Web Application project.
Yes, from Trung Hoang Nguyen at Metropolia University. It's a great case study because it aimed to build a really comprehensive CI/CD pipeline for a React web app called Mumu, kind of inspired by Netflix, actually.
Oh, cool.
And it showcases how all these different tools and practices come together to manage that whole software lifecycle.
Okay, so walk us through the actual flow. Developer makes a code change. Then what? How did they wire this thing up?
Right. So it started, as you expect, with a developer committing code to GitHub. Jenkins, which was acting as the main orchestrator, would automatically pick up that change.
Jenkins, the workhorse.
It's the workhorse, exactly. Jenkins would then kick off a series of stages. First, pull the code, send it straight over to SonarQube for some pretty rigorous quality checks, code style, potential bugs, security vulnerabilities.
So quality gate right at the start.
Yep, baked right in. If the code passed SonarQube's checks, Docker would then step in to containerize the application, packaging it up nice and neat with all its dependencies. That Docker container was then deployed automatically to a dedicated testing environment. If all the tests passed there, it would then be deployed to the production server, which was running on Google Cloud.
Gotcha. Test then prod.
Right. And then, for ongoing visibility, they use Prometheus and Grafana for continuous monitoring of both the application and the infrastructure. Jenkins even set real-time notifications to Telegram about the build status, success, or failure.
That sounds like a really complete system. Okay, let's unpack some of those key tools. Infrastructure as code, or IAC. We know it automates infrastructure setup, but what specific problem did Terraform solve for Mumu on Google Cloud? More than just speed, right?
Definitely more than speed. Terraform, being HashiCorp's open-source IAC tool, brought repeatability and, crucially, consistency. For the Mumu project, their entire Google Cloud setup, the VM for the app itself, DevOps app VM, the Jenkins VM, DevOps Jenkins VM, the SonarQube VM, DevOps SonarQube VM, all of it was defined in simple configuration files.
Code, basically.
Exactly, code. The strategic advantage here isn't just that it's faster to set up, though it's that it eliminates what we call configuration drift.
Where environments slowly become different over time.
Precisely. With Terraform, you have this auditable version control blueprint for your entire environment. It guarantees that every environment, from a developer's laptop setup maybe, to testing, to production, is identical. That drastically cuts down on those "it works here but not there" bugs.
That's huge. Knowing your environment is consistent, traceable, kind of immutable in a way. And speaking of consistency, let's talk Docker and containerization. We know containers package apps. How did Docker specifically boost Mumu's CI/CD efficiency?
Docker was absolutely critical for that consistency and portability within the pipeline. By bundling the Mumu application and all its dependencies libraries, system tools, everything into a single lightweight container image.
Right, the whole package.
They guaranteed it would run exactly the same way everywhere. Developer's machine, testing server, production server on GCP, identical runtime. It directly solves that classic, well, it works on my machine problem.
The oldest excuse in the book.
Exactly. And specifically for CI, it meant that all the automated tests ran in a perfectly isolated, consistent environment every single time. This makes the test results much more reliable and reproducible, which is fundamental if you want to trust your automation for rapid integration.
Yeah, that makes total sense. Reliable tests are key. Okay, so you've got all these pieces, Terraform for infrastructure, Docker for the app package. Something needs to conduct the orchestra. That was Jenkins. But how did Jenkins, working with tools like SonarQube for quality and Prometheus and Grafana for monitoring, ensure not just deployment, but actual quality and visibility?
Right. Jenkins was the central hub, the trigger, managing the whole flow. When a developer pushed code, Jenkins made sure SonarQube immediately scanned it. And SonarQube uses these things called quality gates.
Quality gates, okay.
They're essentially automated checkpoints. Predefined rules for code style, complexity, security vulnerabilities, test coverage, things like that. If the code didn't meet those standards, Jenkins would actually stop the pipeline right there.
So it prevents bad code from even getting close to production.
Exactly. Quality isn't an optional step later. It's a barrier early in the process. And then for ongoing visibility after deployment, Prometheus was constantly scraping real-time metrics from everything the Jenkins server itself, the VMs, the application's performance, resource usage.
Collecting all that data.
All the data. And Grafana then took that raw data and turned it into really intuitive visual dashboards. The Mumu team could instantly see the health of their pipeline, the app, the infrastructure, are builds succeeding, what's the CPU load, memory usage. They could spot trends and potential problems proactively.
It's like having a fully instrumented dashboard for your entire software factory, not just the car coming off the line.
That's a great analogy. It provides that crucial operational intelligence.
So after putting this whole comprehensive pipeline together for Mumu, what were the big results? What kind of efficiencies did they actually achieve?
The efficiency gain was pretty stunning, actually. The entire pipeline, from the moment a developer committed code through testing to full deployment in both the testing and production environments, completed in under 3 minutes.
Under 3 minutes. Seriously, from code commit to live.
Under 3 minutes. That kind of speed isn't just, nice to have. It fundamentally changes how quickly you can deliver value, how fast you can react to market needs or critical security issues.
That's incredible speed. Were there other, maybe less obvious benefits that came out of their approach?
Yeah, a couple of things stood out. Using containerization with Docker was a big win for the development teams. It allowed different teams or individuals to work on separate features in parallel without worrying about stepping on each other's toes with conflicting dependencies.
Avoiding dependency hell.
Exactly. Also, because they designed it modularly and used infrastructure as code so heavily, many of those configurations, the Terraform files, the Jenkins pipeline steps, were reusable.
Right. Build it once, reuse it.
Yeah, it created this foundation, this blueprint that could significantly speed up the setup for future projects. And those real-time Telegram notifications from Jenkins. They might seem small, but they really helped keep everyone in the loop instantly, reinforcing that continuous feedback culture.
That really drives home the point that it's not just theoretical efficiency, it's tangible speed, reliability, and reusability that directly benefits the product and, ultimately, the user.
Absolutely.
Okay, we've covered CI/CD pretty thoroughly. Let's zoom out a little bit. What about GitOps? It's a term we hear more and more. How does that fit into this whole modern development landscape?
GitOps is a really interesting and increasingly popular operational framework. It essentially takes DevOps principles, especially the tooling around CI/CD, and applies them specifically to infrastructure automation and management. The core idea is that the single source of truth, the desired state for your entire infrastructure, all your servers, Kubernetes clusters, network configurations, everything is declaratively defined and version controlled in a Git repository.
So like IAC, but Git is the absolute master record.
Exactly. Git is the source of truth. But here's the twist that makes GitOps unique. You have automated software agents that are constantly observing the actual live state of your system.
Watching what's really running.
Yeah. And they are continuously comparing it to the desired state defined in Git. If there's any difference, maybe someone made a manual change directly on a server.
Uh-oh. Drift.
Drift, exactly. The GitOps agent detects that deviation and automatically reconciles the live system, pulling it back into line with the state defined in Git.
Wow, so it's self-healing infrastructure in a sense.
That's a great way to think about it. It provides incredible consistency, security, because changes are audited through Git commits, and traceability. It's effectively continuous deployment, but for your entire operational environment. And adoption is really taking off. The Cloud Native 2024 survey found something like 77% of respondents were adhering to GitOps principles.
77%. That's huge. Imagine having version control not just for your app, but for your whole server setup, constantly ensuring it's exactly as approved and automatically fixing any rogue changes. That's a powerful concept for control and stability.
It really is.
Okay, one final piece here. With all this incredible automation and speed in deploying code and infrastructure, how do we make sure the pipelines themselves are actually working well? How do we monitor the delivery mechanism?
Ah, yes. CI/CD pipeline monitoring. It's just as critical as monitoring the applications the pipelines deliver. You wouldn't drive a race car without gauges, right?
Good point. So what are we measuring?
We track several key metrics. Things like
Pretty straightforward. How often are successful releases actually getting deployed to production? Daily, hourly, lead time for changes. This is crucial. How long does it take from the moment a developer commits code until that code is running live in production? Mean time to recover, MTTR. We mentioned this earlier. If a deployment does cause a problem, how quickly can you detect it and restore service? Change failure rate. What percentage of your deployments actually result in some kind of failure or require immediate remediation? And sometimes queue time. How long are changes sitting around waiting in the pipeline before being processed?
So it's about measuring the health and efficiency of the factory itself, not just checking the quality of the widgets coming out the other end.
Precisely. High-performing teams are often aiming for things like daily or even hourly deployments, lead times measured in hours or less than a day, and an MTTR of under an hour. But the really insightful part is correlating these pipeline metrics with your application's actual runtime performance metrics.
Ah, connecting the dots.
Exactly. Is a spike in application errors related to a recent deployment? Did a slowdown in the pipeline lead time correlate with higher resource usage later? It allows you to pinpoint whether problems stem from the delivery process, the code itself, or maybe the underlying infrastructure. It's about optimizing that entire value stream from idea to production.
It sounds like a truly holistic view. Building smart, not just fast. Constantly refining the process of how you make software to ensure both speed and rock-solid reliability.
That's the goal. Continuous improvement across the board.
Wow, okay. We have covered a ton of ground today.
Yeah.
We started by unpacking DevOps, not just as buzzwords, but as that fundamental cultural shift towards collaboration and shared responsibility.
Right, and then we dove into the mechanics of CI/CD, continuous integration, delivery, and deployment, seeing them as the powerful automated engine that really drives those DevOps principles in practice.
We saw it come to life with the Mumu Web Application project.
Yeah.
That was fascinating, using Jenkins, Docker, Terraform on Google Cloud, SonarQube, Prometheus, Grafana, all these tools working together.
Yeah, a great example of the ecosystem. And we even looked ahead a bit, touching on the rise of GitOps for infrastructure management and the absolute necessity of monitoring the health of these complex pipelines themselves.
It's really clear that this isn't just a niche thing for developers and operations folks anymore. It's a holistic approach, a philosophy almost, for creating, delivering, and maintaining software that ultimately benefits everyone, the business, the teams, and us, the users.
Absolutely. So maybe as you reflect on this deep dive, here's something to think about. The future of software, and maybe many other fields too, isn't just about what we build, but increasingly about how reliably, consistently, and rapidly we can deliver it. So what old processes in your world, maybe even completely outside of software, could benefit from a dose of this continuous improvement mindset and some smart automation?
That is a powerful thought to chew on. Where else can we apply these ideas? A huge thank you to our sponsor, Stonefly. And definitely check out their latest offering. It's a 100 TB immutable and air-gapped SSO NAS for an incredible $8,995. Really impressive specs. You can find all the details at stonefly.com. Thank you so much for joining us for this deep dive today. Until next time, keep exploring, keep automating, keep learning.